Hello and welcome to today's class. We are going to look at logarithms. So, in our previous classes, we've been looking at the concept of indices. And we mentioned that assuming you're given a number, let's say 2, and that 2 is raised to 0, we all know that that's going to be equal to 1. Remember, any number raised to 0 will always be equal to 1, mathematically speaking. And so, when you raise the same number, let's say 2, two, you realize that you're going to get 4. All right. So by now I know and you understand that 0 and 2 here, which are commonly known as powers, are what we call indices. And of course, indices is just plural for the word index. All right. All right. So you know them as power. You know them as them as power, and now we introduced a new term and we call them index or indices for plural. All right, and of course there's another term as well that is exponent. All right, so if maybe let's say you are trying to figure out other ways of calling the term power in the index, you can also call it exponent. The same thing, nothing really much changes. So the class on logarithm, and the reason why I've introduced these concepts of indices is because the concept of logarithm is related to that of indices. All right, because logarithm is basically short form for the question, what is the index? Okay, so when we talk of a logarithm, all right, when we talk of logarithm, we are basically we are asking a mathematical question, and that is what is the index? What is the index? So that is what logarithm basically means. So it's a mathematical question begging to answer the problem: what is the index? What is the power? Or what is the exponent? Now let us look at a for example here. All right. So if we were to write a, which at this particular point is in an index notation. All right. So these two here are in the form we call index notation. All right, that is A and B there. All right, so those two are in the form called index notation. So if we were to write them, let's say in logarithmic form or logarithmic notation, all right, how would we approach that? That is what that's going to be the main objective of today's session. So if let's say we were to write A, then we'd say what is the power? All right, what is the index? What is the exponent of 2? All right, if we want to get 1, what is the power of 2 if we want to get 1? Of course, we know that will be 0 right there. That will be 0 right there. So that would be for A. All right, so for B we would have the same index notation written as what is the power, that is the log. What is the power of 2? All right, again, if we want to get 4, what is the power of 2 if we want to get 4? What is the logarithm of 4 base 2? All right, that's another way you can refer to it. The log of 4 base 2. All right, so basically what is the power, or what is the index exponent of 2 if we want to get 4? And we can already see that's going to be 2 right there. So one thing I want to maybe introduce in this particular class are the parts that form a logarithmic notation. So in the subscript area right here, this is what we call the base. This is what we call the base. All right, so the base is usually the common base when it comes to the indices. In this particular case is 2, and you can see 2 here. All right, so 2 and 2 in A and 2 in B is what we call the base. The number that is raised to a certain power is what we usually call the base. Okay, so we have logarithms with different bases. We have logarithms with different bases that in fact we can actually give the general form of logarithm as log of n. All right, so n can be any number from 1 to going on to infinity. All right, let's say, and we are trying to find the logarithm, if we of the logarithm of x to base n, and of course let's say it's always going to give us y. So the general format for all logarithmic notation is always going to look like this, where n is the base, and the base, I've told you, is the number that we always raise a power to, and y, all right, y is the index, and y is the index, or you can call it, as you said, you can call it power, all right, or exponent, all right. And so x is usually the number that you get out of raising n to the power y. All right. So this here is but the same as n raised to y to give us x. All right. This here. So this here is an index notation. All right. And whatever we have in the box there is what we call a logarithmic notation. A logarithmic notation, or logarithmic form. All right, so that's it for that slight introduction. Let us look at a few examples, then we call it a day. All right, so for our first example, all right, we are told to write in logarithmic form. So we've been given some problems there in index notation, and we are asked to write them in logarithmic form. So you should be able generally be comfortable to write from index notation to logarithmic notation, and from logarithmic notation to index notation. So we start with this particular here. So remember what logarithm basically means. So we will ask ourselves, what is the power? What is the index? Okay, what is the index if our base is 2? What is the index if our base is 2? That will give us 32. All right, what is the index? What is the power if our base is 2? That will give us 32. Of course, we know that will be 5. Awesome. And so that would be the logarithmic notation in that particular case. Now for B, we'll ask ourselves the same question. What would be the index if our base is 9? If we want to get 3. If our base is 9, we want to get 3. What is our index? What is our power? That would be, and you can already see, would be a half. All right, that would be a half. All right. Finally, what would be the index? Okay, what would be the index given that our base is b? If we want to get m, what would be the index given that our base is b? If we want to get m, and you notice that would be n. All right, so that is for our first example how we go ahead writing index notations to logarithmic forms. Can you, however, be able to write a logarithmic form back to an index notation? Is the question we'll be answering in the last example of this video. Yeah, awesome. For our last example, so we have been told to write in index form. All right, so we are having 3 logarithmic notation, A, B, and C. All right, and we are going to attempt to write these 3 in index form. All right, so we know that that how we read this would be the log of 1000 to the base of 10 is 3. All right, so we know that log basically answers the equation, the index. So whatever we are going to get, we already know that this number here, 3, should be the index, because log basically begs to answer the question of what is the index. All right, so we know that is going to be the power. So what we have to figure out is what our base will be. And when we were looking at the general form of logarithmic notation, we said that the subscript in this particular case, which is 10, would form our base. So we know it would be 10 raised to 3. All right, so we expect that 10 raised to 3 is what will give us 1000. So the index notation for this particular problem, starting with the base, which is 10 in this particular subscript, of course, raised to 3 will be equal to 1000. That will be the index notation for that particular problem right there. Now, for the second problem, of course, we know our base will be 3, so we're going to begin with 3, and of course our power there is 4, so 3 raised to 4, we know that should give us 81. All right, so for the last problem, of course, we know our base is going to be b, and it's raised to 0. So any number raised to 0, of course, from this problem we can see is supposed to give us 1. So that's it for this particular class. Go on and have a wonderful day. If you have any questions, drop it in the comment section, and I'll get back to you as soon as possible. Thank you and adios.